This is Amanda from Zip Automations, and I'm here today to explain the difference between a function and a function block in PLC programming. Now, a function is essentially a block of code that can be reused in multiple instances but with different variables. For instance, we have this line of code, this parameter, whenever it's on, it turns on the output, whenever it's off, it turns off the corresponding output. The parameters have already been defined within the function itself. Then the function has been called. So this is an instance of this function. This is another instance of this function, the same function, but they are working with different variables. So they have the same underlying code, but input and output of the different instances are different. So they're going to work respectively. So let's monitor this to see how the function works. Basically, whenever this is on, it's supposed to turn on the corresponding output. So for this instance, this is on, so therefore this is on. But even though they're using the underlying code, since this variable isn't on, this isn't going to be on. So until I turn this on, that's when this comes on. And so on and so forth. So this function can be called as many times as you need for as many outputs as you need to run the same code for. So now primarily the difference between a function and a function block is that a function does not have a dedicated memory, whereas a function block does. So let's test this using the same code written in a function as opposed to written in a function block. So let's start with, in a function we're going to define the input current volume, the output volume difference. Now what we're trying to do, the code we're trying to write is supposed to calculate the difference between the current volume, the previous volume, and give us that difference. Then the difference is now meant to be stored as the new previous volume. So we're going to define three variables: the current volume, the previous volume, and the volume difference. So the current volume is going to be defined as an input parameter because this is constantly changing and needs to be supplied. The volume difference is the output of the block after all the calculations. This is what you're supposed to see. Then your previous volume is defined in a function as a temp value because this is constantly changing within the function itself. So not from the user input, but through this move block where the volume difference is supposed to be moved into a previous volume, and then this is what is not going to be used in the next cycle of the function. So all of these would be done by the function itself. So this code written in a function and called in the main block. So let's just create a new network, call this. So we're going to create a memory word that was access current volume, a memory word for this too. Download this code and test it. Now to start with, the default values are 0. So the previous volume value is also currently 0. So if the current volume were to be 20, the volume difference is 20 because 20 minus 0, 20. Now what we should expect is that this volume difference now moves into the previous volume parameter. So the current previous volume should be 20. So with the new current volume, let's say 50, it should be 50 minus 20. And we're supposed to see 30. Well, if we were to change this, we'd see that this is 50 instead of 30. This is because for a function, it does not retain the previous value. So the previous volume that was supposed to be saved as 30, as the new cycle came, it resets the previous volume variable. It resets it back to 0. This is because it does not have a dedicated memory. It has nowhere to store that value. So it just resets all the value at the start of the call of the block back to their default values, in this case, which is 0. So because at the start of every new cycle, the previous volume remains 0, your current volume and your volume difference are going to be exactly the same because it's always going to be the current volume minus 0 at every call. So you can see that. And this is if we use a function block, a function. So now let's test this with a function block. So the exact same code, we have our input defined as the current volume, output as the volume difference. Now this previous volume is now going to be defined as a static This doesn't exist in the function, but it exists in the function block. Basically, defining a parameter under static just tells us that whatever is going to be here is not going to be affected by the user input, meaning the user is not going to be able to edit this value, and it's whatever that goes on in the function block that's going to be affecting this value. However, the value in here should be saved, should be so at the end of every cycle, this saves to a DB, saves to a data block, and if you ever need to call the value in previous volume again, you can always use it and access it at cycles to come. So the exact same code, but now previous volume is going to be stored as a static parameter which doesn't exist in the function block, and this is going to help us retain the value of previous volume even as the block is called again for a next cycle. So the same code as written in the function, the current volume and previous volume is subtraction to give us the volume difference. Then the value in the volume difference should be moved to the previous volume, and we'll see. So now let's call this function block into the main block. So the function block, we'll call it. So now with a function block, it asks you to automatically create something called a data block, and this is the retentive memory for the function block. Basically, this is where it saves all the dedicated values, all the values that you need to save in the function block. This is where this is going to be saved. So like the function, we're also going to create a memory word to be able to access this. Now, to make sure that the function and the function block are only called when you want it to be called and not continuously performing the subtraction, we're going to create a positive edge trigger in front of the function and the function block. So it's only when that trigger is activated that's going to run the mathematical cycle. So we're just going to do that now. So after the positive edge triggers have been created for both function blocks and function, we can now add a watch table to monitor the values of the respective functions and function blocks. So now this is the trigger. As this trigger is turned on and off, it's going to change the value in current volume, and then it's going to run the mathematical equation and then give us the output in volume difference. This current volume variable is from the function, same thing with the volume difference. Current volume 2 is the variable from the function block, and the volume difference 2 is variable from also the function block. So we can also test the function again here. Just change the current volume to, let's say, 90. So if you notice, that's giving us the corresponding volume difference, and it still remains as 90 because the previous volume will always be 0 because this is the function. So now we're going to try this with the function block. So let's give our current volume to be 30. And now we're going to run the trigger. So if you notice, volume difference as expected is also 30 because this is the first time we've run the function block and the previous volume is still 0. So I'm going to make our current volume now 80. So now that it's 80, we should expect that our new volume difference when we trigger the mathematical cycle is that it will be 80 minus 30. We're supposed to get 50. And as we can see, it's giving us 50 because from the previous cycle that we had already run it, the previous volume was supposed to be 30 because the volume difference we're giving was 30. That value of 30 was moved. So it works. We can see that it works. We can see that it stored the value of 30 for the volume difference, and now when we needed to use it in the next cycle, it did 80 minus that 30. If we try this again, it's supposed to be, let's call this 100. Let's make this 120 so it's easier to know. So now that this is 120, we should expect that when we run the trigger, it should give us 120 minus 50, because 50 was the previous volume difference, and that should be what our previous volume value should now be. So now when we subtract, we should have 120 minus the previous volume, which was 50, and now we have 70. So we can see that every instance, the value inside the previous volume is saved at the end of its cycle, and we can use it in subsequent times. It just shows that with a function, you have no dedicated memory, whereas with a function block, you have the dedicated memory. So you can use it whenever you need to call things that were done in a previous scan, a previous cycle of that function block. Thank you for watching.